What's the big idea behind scientific notation? What's so scientific about it anyways? Really nothing. The only reason they call it scientific notation is because it's the method of writing numbers that scientists prefer. Because scientists deal with a lot of massive numbers, like the distance to the sun or the mass of the earth. Yes, they've calculated that. Those are enormous numbers. And they also deal with really tiny numbers, like the mass of a bacteria. So rather than writing all of those digits, they've discovered a fast way of writing the same number, but that would save them some time and space on paper. So from now on, and especially once you get to high school and college or university, you're going to be seeing most of your numbers, if you go to the sciences or the mathematics, you're going to be seeing a lot of those numbers written in scientific notation form. Before we start with the technicalities of scientific notation, we are going to be starting with a little bit of a warm-up. So let's start this. 5 times 1,000 is 5,000. Okay, great. But how did that answer come to be? Well, for one thing, we have 5,000. Okay, we understand that. But what really happened here? Let's look at it comprehensive. Let's look at it in detail. What really happened is those 3 zeros moved the decimal spot that was originally here and bounced it 3 times to the right. And now it's 5,000. And then we can erase all of those spots here and make it look pretty. And we've got 5,000. That's all. So we can take that same idea and apply it here. We have 3 zeros. So we're going to bounce that decimal 3 times. So it's going to start here between the 3 and the 2. It's going to go 1, 2. Let's do that. We'll go 1, 2, 3. Put a decimal here and fill the spot with a 0. Any spots that are any valleys that are empty, just put zeros in them. And then you've got yourself 5,320. And then this one here, we've got 5.32 times 10 to the third. What's 10 to the third? Well, you know 10 to the third is just 10 times 10 times 10, which is 1,000, right? 10 times 10 is 100. 100 times 10 is 1,000. So this is really the same as this question here. We can scratch this out and we can say it's 1,000. Look at that. 3, 3. You see the pattern, what's going on here? So all we do is just move the decimal 3 times. That 3 tells us how many times to move the decimal once you see it in this form. So don't be scared off by it. And don't even bother changing it to 1,000. Just look at the 3 and bounce it 3 times. Now here we have 5.32 times 10 to the negative 3. And 10 to the negative 3 is, well, it really is just 1 over 10 to the 3. We're going to learn about that once we do negative exponents. And that's just going to be 1 over 1,000. And without complicating things too much, I'm just going to say do this. Move that decimal 3 times, but don't move it to the right like what we did over here. That's a negative. So the decimal's going to go 3 times to the left. Okay, you see what's going on here now? So if it's a positive, it goes to the right. If it's a negative, it just goes to the left 3 times. We've got 1, 2, 3. Put it there. We're going to put a 0 on this end, and any values are going to end up with zeros. So we have 0.005532. And then we erase these. Don't keep them, just erase them. Keep the decimal though. Now what do we have here? We have 532 times 10 to the negative 3. So that negative 3 means we're going to have to move the decimal 3 to the left. But where's the decimal? If you don't see the decimal, where do you look? Here? No. Here, yes. So just take it. Yeah, every time you don't see decimal, it's always sitting right there. Just waiting. So we have 1, 2, 3. Let it land here. Make it 0.532. And then do the eraser marks there. Now, what I did here is wrong. I should write out the answer again. Okay, so I'm not going to do this. I'm going to rewrite it out. I'm going to say 532. 532. Decimals here. I'm going to go 1, 2, 3. Let it land there. Don't write it part of the question because now you're changing the question. Write it as part of an answer. Separate from the question. And we've got decimal 532. Great. That's our warm-up. And that's going to help us do scientific notation because these numbers here, this one here is, well, let me show you. Okay, write these numbers in scientific notation. Listen, it's only 3 steps. That's all you have to memorize. And they're not that hard. Step 1, locate the decimal. Is that hard? Where's it over here? It's over on the end. I'm going to rewrite this number. Okay, locate the decimal. Must form a number between 1 and 10. What does that mean? Well, it just means put the decimal between these two numbers, because then you get 2.4. And guess what? 2.4 is between 1 and 10. So 2.4506. So basically it's almost 2.5. 2.4 is almost 2.5. And then you multiply by a power of 10. I'm going to times this number by 10 to the power of something. Look, the decimal was on the right side, so I need to get that decimal back to the end. How many times did I move it? Well, I moved it 1, 2, 3, 4. Now look, the decimal's on the, now to move it back, I have to go 1. I have to go in the positive. I got to go 1, 2, 3. I've got to go 4 times 4. So I'm going to go positive 4. If the decimal's on the right side of the number, to start with, it's always going to be a positive exponent. Think of it that way. Now the next question, we have 3,700. Okay, locate the decimal. It's right at the end. Step 2, must form a number between 1 and 10. Okay, so we're going to put the decimal here between these two. If I put it after the 7, I'm going to get 37. Is that between 1 and 10? Of course not. So I have to put it between these two digits here. I'm going to get 3.7. Now look, how many times did I move it? I moved it 1, 2, 3. There's 3 spots. I'm going to put times 10 to the 3. Okay, don't put negative 3. Here's where confusion sometimes occurs. People think, or students think that, okay, I moved it backwards 3, so that means I've got to put negative 3, right? No. Because if you put negative 3, you're telling this decimal that it's got to go back 3 again. We don't want that. We got to make this a positive 3. Right. So it can go back to the right side and reform this number here. Okay, let's test it out. Positive 3. We're going to take this decimal. We're going to move it to the right. We're going to go 1, 2, 3. And we got 3,700. If I left that as negative 3, it would have formed this. It would have went 1, 2, 3, put that there, and you would have got 0.0037. Okay, that's obviously not the same as 3,700. So we are going to erase that. That's gone. And we have, let's make some space. We'll leave it like this. Here's another area students get the wrong answer. They go 3.7. They'll get that right, but then they'll just go 3 to the 3. And they'll go positive 3 because it's going to the right. Okay, you know what? That's wrong. We need to multiply by 10 to the 3. So don't forget the 10. I'm going to test you in a bit on this, so make sure you understand that part. Now the last one, 4,500,000, written in scientific notation, makes what? Try it on your own. See if yours matches mine. 1, 2, 3, 4, 5, 6. Did you get this? Great. Write in scientific notation. Now we've got some practice over here. Now if you think you understand it, you don't have to watch the rest of this video. Or you could. We're gonna make a number here between 1 and 10. That's step 1. So we'll go 8.32. Now we have to multiply by 10 to the power of, well, let's see. We went 1, 2, 3, 4. But it's on the left side, so we're going to be negative 4. Done. Do this one. Now that's technically not necessary to write in scientific notation. It's already a very short number, but we'll do it anyways. We'll go 1.5. That's between 1 and 10. Multiplied by 10 to the, just moved it 1 time. It's on the left, so negative 1. Let's go to this one. We're going to make 2.8 times 10 to the 1, 2, 3. It's on the left, so negative 3. And this one here, that's a lot. See, that's where scientific notation comes in handy. When you got all these digits, why are you wasting your time writing them? Just go like this. Go 2.1. Now, the zero is optional. I'll put it in. Times 10 to the, we got to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But it's on the left side, so I'm going to go negative 10. Now, these state to write in standard form. So we have to write them as a complete number. We're going to have to write all the digits. So if you see standard form, it just means regular number. 5.1 times 10 to the 3. We're going to take that 5.1. We're going to take the decimal in it. We're going to go 1, 2, 3 because it's positive 3. We're going to go, now look at my funny 5. It looks like an S. We're going to go 1, 2, 3, pop it there, and then erase, and you get 5,100. Here we've got 2.63, but we have a -5, so we've got to go to the left. We're going to take it to the left. 1, 2, 3, 4, 5. Plop it down. We're going to put all the zeros in, and then we're going to erase all of these. Keep the decimal. We need it. Don't erase the decimal. We need those decimals. And then we've got our answer. And I'll fix the 2. Now, 4.8 times 10 to the -7, we're going to go like this. All right, 4.8. I know the decimals here. I've got to take it. Oh, wow, 7 times. That's a lot. 1, 2, 3, 4, 5, 6, 7. I'll squish it in. 0, 0, 0, 0, 0, 0. You see why it's a pain to write? Scientific notation is so much easier. And we've got 4.8 times 10 to the +11. So we've got to go +1, +2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then, the best part. 0, 0, 0, 0, 0, 0, 0. Oh my God, they're getting squished. 0. And we'll put the commas in just to, I'm not going to even bother erasing this. I'm going to go 3. We're going to sort these numbers out into scientific notation or the ones that are trying to trick us and are not actually scientific notation. Look at the first one. Is it or is it not? Well, let's test it out. Is it between 1 and 10? Yes. 5.4 is between 1 and 10. Does it have multiplied by 10 to the something? Yes. Okay, it looks good. How about this one? Yeah, this one looks all right. Between 1 and 10 times 10 to the something. Okay, this works. How about this one? It looks good, right? Between 1 and... Oh, no. 0.3 isn't between 1 and 10. Goes into the pits. How about 10 to the 5? No. No, not... Because we're not we need to multiply it by something. Now, technically, yes, it is 1 times 10. If you don't see anything, obviously we're timesing by 1. But because we didn't write it in, you could argue this, but it commonly stands as invalid. So we're going to throw it in the pits. How about this one? No, absolutely no. Because look, 54 isn't between 1 and 10. Yeah, sure, this part's in, but this part's messed up. So we'll put it in the fire. Burn it. How about this? Times 10 to the -18 looks good, but look at the first part. It's not between 1 and 10. You have to put it between 1 and 10. That's the rule. This one, same reason. Throw it in there. And this one looks good, between 1 and 10, and this one is 10 to the -18. Now, remember I was saying some of the numbers scientists deal with are massive. For instance, let me show you the mass of the Earth. If I was to write down the mass of the Earth, I would have to write down 5, 9, 7, and then 22 zeros. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. I lost count. Write 22 zeros. 22 zeros. And then put kilograms. That's the mass of the Earth. They've calculated it out. Now look, obviously nobody wants to write all these zeros. So instead of doing all this, they just stated in scientific notation, the scientists do, and they say it's 5.97 times 10 to the +24 kilograms. And it saves time and space. Now look, here's another example. The mass of a bacteria. If you were to take a bacteria, they're invisible to the naked eye. You stick it on a scale for bacteria. I don't know what that looks like. But if you did, this is what an average bacteria would weigh. 0.000000000, let's say 95 grams. That's, oh my God. Now look, that took a lot of space and time and effort. I could just write 9.5 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10 to the -9 grams. I'm done. Simple way of doing it. And that's why scientists love using this.